Hi there, it's Jason Gorman from Codemanship with another video in our series aimed at JavaScript developers on Codecraft. In this video we're going to be focusing on the discipline of refactoring. Refactoring is improving the internal design of our software without changing what it does. It's making our code more maintainable, easier to change, without breaking it. And it's a very, very important discipline in programming. Whether you're doing agile programming or any other kind of programming, the ability to keep code easy to understand, as simple as possible, to remove duplication from our code and to tackle those problem dependencies so that our code is going to be easy to change going forward as we get more and more new requirements and as our code grows and evolves, I would argue is probably the second most important skill for a software developer. The first most important, of course, being communication. It's a very, very valuable and very, very underrated and undervalued skill. And in this video, we're going to be focusing on how it works, and we're going to be looking at how I do refactoring. And we'll also be talking about the rationale for it. Why do we refactor? And to illustrate that, I'm going to be using our Mars rover example. So if you watch our previous videos on test-driven development, the Mars rover exercise essentially is one where we test drive some code that drives a Mars rover across an idealized grid that represents the surface of Mars. So the rover has X, Y coordinates, and it can move northeast, south and west, forwards or backwards. And we send it sequences of instructions, F for forward, B for back, R for turn right, L for turn left. And it interprets that sequence and moves the rover across the grid. So that's the simplified version of it. So I've test-driven an implementation of that, and at the end of that, I've got a whole bunch of unit tests for our Mars rover, 17 in total. So I've got pretty good confidence that if these tests are passing, then our rover is working. But my code here has some design problems. It has some code quality bugs, if you like, that we would call code smells. Code smells are indications that our code essentially is rotting. It's getting more complicated. It's getting harder to understand. It's filling up with lots of duplication and all that kind of nasty stuff. That going forward means our code is going to become rigid, difficult to change, and brittle, easy to break. Now, before I refactor this code to eliminate the code smells in it, I need to put my seatbelts on, safety first, and the refactoring discipline is all about restructuring our code safely. So safety is really important. Now, there are three ways that we achieve safety in refactoring. Way number one is we have good, fast running tests. The longer it takes us to find out if the change we've just made has broken the code, the harder it's going to be to make those changes without breaking the code. So we've got fast running tests. So before I do any refactorings at all, what I'm going to do is I'm going to run my tests just to make sure they're all passing. If any tests are failing, that means there are holes in my safety net and it's not safe to do refactorings. Okay, now let's take a look at our package.json file here. Okay, so I'm going to set up a target called test in my scripts section here that's going to instruct it to run any mocker tests that it finds in the test folder. So I've got a rover underscore test module here, which has got a bunch of mocker tests in them. And it will know automatically when I run this using npm to look for those tests and execute them. So let's save that and run our test. Oops. npm test. Okay, there. All 17 tests are passing. Now, I could, of course, I'm working in WebStorm from JetBrains. I could, of course, run that within the IDE very, very easily. Just like, let's just find our tests here. Let's run those from there. So we could just as easily have done that. But for the purposes of demonstration, I am well aware of the fact that a lot of JavaScript developers don't use these kind of full-blown IDEs. They use these much leaner, kind of stripped down editors like VS Code and Atom and wonderful things like that, that don't have quite as much support for these wonderful automated things like automated test runs and stuff like that. Some do, some don't. So what I'm going to do to begin with is I'm going to pretend that I don't have these things because I'm using WebStorm, which has a lot of wonderful tools and widgets and doobries. But I'm going to pretend I don't have them to begin with, to just sort of give you a feel for, because you might say, oh, but he's using these tools and therefore this doesn't apply to me because I don't have these tools. Well, you can still do these things without these tools. It's harder. You need to be more disciplined, but you can do them. So the tests are passing. Let's go back to our terminal window there. The tests are passing, and that's the first part of putting on our seatbelt. The next sort of part of achieving safety when we're refactoring is the ability to get back to working software very easily. And for that, sometimes undo is not good enough. So we need version control. So what I'm going to do is I'm going to make sure, let's just see what happens if I try to commit this. Now I've changed one of the files, so let's make sure that we've got that saved. Set up test script in package listen to use to run mocker tests. That's what I did, and hopefully that will, there we go. So we've got a version that we can get back to very easily. You're going to see me doing that quite frequently as we go. So safety in terms of refactoring. First of all, fast running tests. So we're going to be running those quite a lot to make sure that our code is still working. So you need tests that you can have confidence in. If you don't, then you need to write some. The next thing is version control. You need to be committing to your local sandbox in particular pretty frequently so that if you do make a boo-boo, it's very easy to get back. Don't rely on undo, and don't go wandering off the path of working code into the deep dark forest for hours and hours and hours with, you know, non-working code in the debugger going, why is it not working? Why is it not working? You need to be able to get back easily. And for that, we have version control. That's really what it's for. And the third thing we're going to be doing, which is very much the whole discipline of refactoring, is we're going to be taking baby steps. So refactoring is both a verb and a noun. So we can say that he is refactoring, she is refactoring, they are refactoring. But there are also such things as refactorings. And these are a bit like the moves in chess. They're very explicit, well-defined rewrites of the code that at the end of which the code should still work. So think of them as being like transactions against the structure of the code. And they must be executed as a complete step. It's all or nothing. And they all have names, and you need to learn the names, and they all have sort of mechanics like the moves in judo. And you need to practice those mechanics. And we use these to address these code smells in our code. So let's take a look at this code. Now, the first thing that sort of jumps out at me, code smell number one, is that all our tests and our implementation of this go function for our rover are in the same module. This is a code smell called divergent change. It's when a module has more than one reason to change, or it's got more than one responsibility. It's doing more than one thing. And what we should do here is we should split this up. So what I'm going to do is I'm going to extract a new module that's going to contain this go function. I'm going to move the go function into this new module. So it's a single refactoring, as you'll see. And I'm going to do this manually to begin with. I'm not going to use the automated extract tool. Just to show a bit of solidarity with you script kidders who enjoy working in VS Code or other platforms that don't have the same level as JetBrains for this kind of automation. So let's do it manually. First thing I'm going to do is I'm going to cut the code that I want to abstract, and I'm going to replace it with a reference. In this case, I'm going to replace it with an import. So I'm going to put it in the root folder, I think, in a module called rover. Okay, now, that's not a complete refactoring. If I tried to run my tests now, well, let's just show you. This is what will happen. Nope, doesn't like that at all because the code doesn't even compile at the moment. So we need to complete the transaction, complete the refactoring by creating this module, rover, in the place where we expect it to be. And then I need to export it. There we go. That is the complete refactoring. At the end of that, we prove that by seeing our tests pass. And there we go. All our 17 tests are passing. So that is good news. That's refactoring number one. And that is the kind of the baby step iterative process of refactoring. The loop goes, you perform a refactoring and then you run your tests. And then you perform another refactoring and run your tests, and then another refactoring and run your tests. So I've just extracted a module. And if anything goes wrong going forward from here, I'd like to be able to easily get back to this working code. So the next thing I'm going to do is I'm going to commit this change. So extracted rover JS module with go function. So I'm sort of documenting the refactoring I did there. And off we go. Lovely. Right, so seatbelts on. We're ready to go for another refactoring. Okay, now let's take a look at this go function. It's pretty long, nested ifs, all sorts of nasty things going on. So when we have a long function or a long method, we can break that down by extracting parts of this into their own helper method. So let's start with this code here, for example. What is this code here doing? It's turning the rover to the right. So let's extract this into a function that describes that with the name of the function. And again, I'm going to do this one manually. So mechanics are, first of all, let's cut the code we want to extract into the function. And then we, similar to when we extracted the module, we replace that with a reference to that function. We're going to call that function. Let's call it right. And it'll need a rover because that code that we cut there is referencing a rover. There we go. So we create our function, we paste in our code like so. And now again, that's a single refactoring. We extracted a function. So that means that we should be able to see our tests pass. Take nobody's word for it. See the tests pass. There we go, 17 passing tests. Seatbelts on. There we go. No, it doesn't like that. Okay. Aha, I know what I've done here. I forgot to add that. Okay, good. Now let's commit that. Now, in a larger code base, of course, these comments would need to be more specific about where these things can be found in the code. But since we have so little code, I don't think I need to do that. Okay, there we go. There's our seatbelts on, which means we're safe to do another refactoring. We can kind of rinse and repeat here. This code turns the rover to the left. Now, this time what I'm going to do is I'm going to take a look on my refactoring menu. So I've got a bunch of automated refactorings that will do the whole thing for me. So it will cut the code, declare the new function, paste the code in, and also point any references. So for example, if I wanted to change the name of the parameter from rover to something else, it would change that name in all of the references to it inside that new function. Now, in JetBrains, they call it extract method, but it works on functions as well, so that's fine. Let's make that global, and we're going to call this one left. And you see how it did that as a single step, a single atomic step, at the end of which, there we go, Passing, lovely. Seatbelts on. Okay. No, git commit. Silly Jason. Okay, seatbelts are on, which means we can do another refactoring. And now it's going to be easier because I'm using my automated tools. Let's call this one forward. And let's run our tests. So tiny baby steps. And we make sure after each step that the code is running, and I am in the habit of also putting my seatbelts on and making sure that I can easily get back to a working version. Or if I take a wrong turn with my refactorings and I end up with a design that works, it passes the test, but I'm not happy with the design, I can easily step back. It's a bit like an undo history of design decisions. I can step back through these design decisions and pick my way back to a design that I like. I can sort of see where it all went wrong. There we go. Seatbelts on. And finally, this code moves the rover back. So, and immediately we run our tests. Lovely, all green. Seatbelts on. Git commit Jason. And this time we've extracted a back function. Now the names of these functions are documenting what the code inside them does. So we're kind of a double win here. We're breaking down this long, complicated Go method and making it simpler, but we're also documenting what each of those blocks of code was actually doing. There we go, seatbelts on. So there's a bunch of refactorings that we've done there. And remember that at this point, I'm only committing to my local sandbox. I haven't pushed this to the remote repository. When would I push it to the remote repository? Well, we'll discuss that later. But for now, this is all fine. So we've got right, left, forward and back. So an internal design is starting to emerge here. And this is often what happens when we break things down with refactoring. Internal designs emerge. Now, let's take a look at this right function here. Again, there's a lot of if statements and a lot of duplication. So I'm not happy about that. What could we do to break this down? Well, we could replace it with something that's simpler and more dynamic. For example, let's imagine we have a compass with our directions north, east, south and west. So there's our compass. That should be equals. And there we go. Now what am I going to do with this compass? Well, I want to know, in terms of the direction I'm facing in, what's its index in the compass? And then I can return, instead of using those if statements, I can return a rover that basically goes to the next direction in the compass. Now, could be as simple as that, but there's a problem. If we're west, then we're at the end of the array. So to stop us from going over the end of the array, so current direction plus 1 for west would be an index of 4, which would be out of bounds. But if we were to use the modulus of that by 4, then 4 becomes 0. And essentially we go round the compass again. Go back to the beginning. So there's, again, that's a single refactoring, at the end of which that code, those 3 lines should do exactly what all the subsequent lines were doing, which means all of our tests should pass, but they do not. Interesting. Silly Billy Jason. Index of. If you can't see straight away what the problem is when the tests are failing, that's what version control is for. So there's an easy way to get back. But here I can see that it's this. There we go. So we should be able to get back to working code. There we go. So it's working, which means since this code is now unreachable, we can safe delete it. A safe delete is a refactoring where we delete code that's not being referenced. In this case, it's dead code. So we safe delete the dead code. And as soon as we've done that, again, take nobody's word for it. Let's run our tests. So see how often I'm running these tests now after each of these baby steps. And seatbelts on. So I replaced if statements in right with an array lookup. There we go. Lovely. Seatbelts on. Now, about the left function, we could do that again, but I think, as far as I can see, the only difference between turning left and right is the orientation of the compass. So if we're going clockwise, that's turning right. We go northeast, southwest. If we're turning left, we go anti-clockwise, which is northwest, southeast. So the only bit that's actually different is that. What I could do, let's extract a function there. I'm just going to call that turn. And let's rerun our tests. Lovely. Okay, now, here's a convention. I'm not going to commit this just yet because there's a little bit more that I want to do to this before I commit this. As a convention, when I'm doing functional programming, I'm still kind of thinking objects. So what is the object of the turn function? It's the rover. And in my world, the object is always the first parameter. It's not turning the compass, it's turning the rover. Therefore, we're going to change the signature of this. So this is an automated refactoring called change signature to just flip those parameters around so that the object comes first. There we go. And even though it's a tiny, tiny refactoring, we're going to run the test. And you'll see what it's done where we're calling that turn function. It's flipped the values that are being passed in around to match. So it does it all in one go, which I find very, very helpful. Okay, and one last bit of cleanup. I'm going to inline compass. We don't need that as a local variable anymore. PM test. So I did a bunch of refactorings there, but that all adds up to git commit. So be reused by left. So I said, in actual fact, from right. No, that's not right. That can be reused by left. There we go. So that's what I was thinking there. Off we go. Lovely. Seatbelts on. Now we have this reusable function. We don't need this anymore. We can just reuse it. The opposite of duplication is reuse. So we pass in our rover, that's the object, but now our compass moves the other way around. It moves anti-clockwise, north, west, south and east. Oops. And Butterfingers today. So, having done that, retest. And seatbelts on. Okay, lots more to do, but I'm going to do a little bit more refactoring now, just so you can get a feel for this. We're going to leave forward and back. That's something that I would carry on to do, but I'm going to do one more refactoring just to illustrate the process just one more time. Now, in our Go function, it's much improved. It's much smaller. We've got right, left, forward, and back now being described by the code. And that's always a good thing. The code clearly communicates its intent much more clearly. But I'm not so keen on these, essentially these lookups here. So we're looking up which of these functions we should call. So I'm going to perform a refactoring called replace conditional with polymorphism. And I'm going to replace it with a real lookup against a dictionary, which would make more sense to me. Now, I've said the P word, polymorphism, and you might be thinking, but you don't have polymorphism in functional programming. Well, actually you do. Duck typing is a form of polymorphism. Essentially, if a function looks the same from the outside and can be used in the same way by the same clients, in other words, if it quacks like a duck, then that's polymorphic. It's just it's not object-oriented. That's the only difference. So what we're going to do is we're going to create a dictionary of these functions. Let's call this dictionary commands that will map our individual instructions onto a particular function, like right and left and forward and back. And you'll see in a minute why I've done this. So rather than looking it up with these if statements, what we're actually going to do is we're going to just look up which of these commands we should be using based on the instruction that we're handling. And then we're going to invoke that command using our rover, which should work exactly the same. Let's find out. There we go. All our tests are passing. We removed all those nasty if statements, and we've clearly sort of documented now which commands map onto which function. So R is right, and L is left, and F is forward, and B is back. So hopefully it's easier to understand now as well, but it also means that our Go function is much, much smaller and much more elegant, in my opinion, as well as being more self-describing. Now we could do a similar thing for forward and back. Again, these are lookups. If you're facing north, then you should move in this direction, etc., etc. So we could probably refactor this to use dictionaries of vectors, x and y. So, you know, x might be, if we're moving north, x might be 0 and y might be 1. Move 1 in the north direction, in the y direction, and so on and so forth. So we could probably do something similar with that, but I'm not going to do that because that is the end of the video. Now, here's the question. I've been committing to my local sandbox, and if we take a look at our Git log, you'll see that there's kind of a history now of all these refactorings that we performed. So it's kind of like a history of the evolution of the code. And each of these design decisions or groups of design decisions have been documented in these. And I quite like this, not just so that I can get back to the way the code was at any particular point when it was working, but also because I quite often like to sit and review these logs to see how I've actually tackled a particular problem. So if you wanted to learn how to do a particular refactoring or how code was refactored, you could always play it back. It's almost like a script, a refactoring script, as well as an undo history. So I like to retain these. Now, at some point, I will have achieved my goal. Once I've refactored forward and back, I will be relatively happy with this, that I've achieved the goal of simplifying or breaking down or cleaning up the Go function, the big nasty Go function. At which point I would consider pushing that to the remote repository to share with the other people on the team. Now, the last discipline in refactoring is that we don't spring huge numbers of changes on the team, structural changes to the code on the team at the same time in one go. What we do is we drip feed them. So we do a bunch of refactorings to achieve some goal, and then maybe after half an hour, 20 minutes, we push that to the remote so that the other team can then fetch that and update their code locally, so that we're only springing a few changes on them at a time. The number of times I've been working on a team and someone has literally just renamed everything and moved everything and deleted folders and just changed it all while everyone else has been working on it. And then they've just committed all those they pushed all of those changes in one go, and it's a complete train wreck. All of a sudden, we're all working with files that don't exist anymore. So don't do that. Push pretty frequently. So continuous integration is a very good idea of your refactoring. Now, some people, they will commit very frequently to their local sandbox, but when they push or before they push, they will squash all of that commit history down to a single commit with a single message. And that does mean that yeah, on your remote repository, on your sort of shared repository, you have thousands and thousands and thousands of commit messages. But you also no longer have that refactoring history, that history of design decisions that were made, and the ability to replay those, to learn from them, and to understand how the code is, how the architecture has evolved. So you lose something very, very useful. So what I do is I push relatively frequently, maybe every 15 or 20 minutes after I've achieved some higher level goal in my refactorings. But what I will do is I will label that final commit. So I won't squash them all down. I'll create a labeled version of the code so that we've got kind of two levels of organization. We've got the commit history, but we've also got the labels for the actual merges to the remote, so that to the master branch, so that we can kind of play it at two speeds, if you like. So that's the refactoring discipline. The important things to remember are baby steps and safety. Safety, very, very important. If you want to learn more about refactoring, about code smells and the kinds of refactorings that you can use to fix those code smells, I highly recommend reading Martin Fowler's book of the same name. It's just called Refactoring. And I'll post a link in the description below. Don't just read the book, though. Refactoring, like a lot of these skills that we're demonstrating, is a practical discipline like riding a bicycle. You can't learn to ride a bicycle from reading a book. You've got to ride some bicycles. So don't just read the book. Try out the ideas. Get some practice on your own code, or code that you've created specifically, or code that you might find on the internet, of which there's much that needs refactoring, as long as it has tests. So 3 things to remember are baby steps, test, running the tests all the time, and version control. Those are your seatbelts so that you can easily get back if things go wrong. There you go. That's the refactoring discipline. It is a very, very valuable skill for a programmer. Unfortunately, it's very, very underrated. You very rarely hear people asking for it in job specs, for example, which is a real shame, because it's what separates the wheat from the chaff. The cream of the crop, if you like, in software development are always, without any exceptions, very good at refactoring. Very important skill. There you go. More videos coming soon for JavaScript developers. If you want to be notified, then ring the bell or subscribe to this channel, and I will see you in the next one.